Hi, my name is Assunta Daprano, and I am a Deputy Project Manager at AECOM in Philadelphia. And this is Meet and Greet March with the Young Professionals in Transportation Philadelphia chapter. And today I'm going to be providing an introduction into railroad engineering. A little bit about myself before we get started. I have a Bachelor's of Science degree in Civil Engineering from Drexel University, as well as a graduate certificate in Railroad Engineering from the University of Delaware. I'm very involved in, professional sections, specifically the American Society of Civil Engineers. I'm involved both at the local as well as national level. And I'm involved in the Engineers Club of Philadelphia, as well as the Delaware Valley Engineers Week. So just a quick railroad safety minute. You always want to look both ways before crossing any railroad tracks. And you also only want to be crossing at designated crosswalks for pedestrians. So you don't want to be crossing the tracks kind of in the middle of nowhere. That can be, pretty unsafe. A train can be coming at any time from any direction. So it's best to cross at crosswalks. You want to make sure you're obeying all signs and signals. So I want to make sure, again, you're not crossing where you're not supposed to be, waiting for signs to activate or signals to go down before you're crossing. Remember, the railroad tracks are only for trains. They're not for people. Make sure you're not walking along the right of way or walking on the tracks. And then lastly, never try to outrun a train. Trains can be going anywhere up to 120 miles per hour. So it's very hard for any of us to outrun a train. If you miss the train, just wait for the next one. Not worth trying to jump on the train. So just a brief railroad history. So railroads first began in the United States with the B&O Railroad. It's actually out of Baltimore. And that was back in 1828. At the time, Baltimore was a fast-growing city. It's right on the water, so it has pretty good port system. And the government felt that Baltimore was the perfect city to start expanding railroads and moving railroads up along the East Coast and then going west during kind of the western expansion. Today, there are 7 Class 1 railroads. And they're all designated on this map here, along with multiple short lines and other different class railroads, as well as with Amtrak and then, other commuter rail agencies such as SEPTA. The Class 1 railroads have about 95,000 miles of track, and about a third of the goods in the United States are still transported by rail. So definitely a thriving industry, an industry that is going to be around for a very long time. So within railroad engineering, what does that mean? So it means the design, construction, and operation of rail transport systems. So similar to highway engineering, where you're building highways, such as the one in this photo, railroad engineering focuses on the building of track. So where is the train going? How is it going to get from point A to point B? If you're working in the passenger side of the world, where are you putting your stations? Things like that. Under the umbrella of railroad engineering, we do also have track inspection. So we do need to inspect the track and provide recommendation on if rail needs to be replaced, or if maybe there's a length of track having a drainage issue. So what kind of recommendations can a track inspector provide? We also do train control and at-grade crossing analysis. So this would be if you have a grade crossing, we can provide recommendations on if that crossing should be removed, and maybe if the grade crossing is removed and you come in with a bridge, or a series of grade crossings can be closed to put one main grade crossing. That way there's, less areas where a train could have impact with a vehicle or pedestrian, to kind of limit the amount of grade crossings we have along corridors. And then lastly, we do a lot of program and construction management, which is something I've greatly focused on the past, especially year of my career, and I'll talk about a little bit further in the presentation. So this is just some, various images that we think about when we think about track design. So the first one on the top left, that's your kind of standard track structure. So you have your rail, your fasteners. You can have either concrete or wood ties. So you'll see in the bottom left photo, those are wood ties, but you can also have concrete. If you ride SEPTA Regional Rail, you probably see a fair amount of concrete ties. Underneath that, the first layer of stone that is very visible when you're standing along track, that is called the ballast. And then underneath the ballast, the part that's, not really visible, or it shouldn't be visible, if you do see that part, we probably have a track problem, is the sub-ballast. So that's more compacted stone underneath this bigger gradient of stone on top of that is the ballast. And then underneath is your subgrade. So depending on what the soil conditions are in the area that you're building track, sometimes that foundation is good enough, or sometimes we need a truck-in material to build a good compact subgrade before the subballast gets put in. One other thing that is starting to be implemented more and more, especially as more products are released and research is done, is the use of geosynthetics or geotextiles. These help the track drain better. They help with stability issues. So we are seeing geosynthetics and geotextiles be used more and more in track engineering. The top right-hand photo, that is actually a frog. So it's kind of funny that it's called a frog. I guess it looks like it could be a frog if it was like extended outwards. But that is, if you have a train on a single track, that frog can move in either direction, so the track knows which the train knows which direction it needs to go to. So it'll have either it can be done by hand, or now they're being done more mechanically, where a piece of the rail will actually move and the train will know which direction it needs to go in. Similar to when you're turning your steering wheel and going, in one direction or in the other direction. And then the bottom two are just another couple photos. So another great photo of what the rail and fasteners and bolts and spikes look like when we look at rail track. That's that bottom left photo. And then the bottom right photo, that would be a turnout. So we'll see these a lot, especially tracks that are going into a yard for maintenance, or if you have a track going into, let's say an industry. So let's say, FedEx is using trains to move mail. You might see turnouts like that, would go into the industry. So just some different types of track work that you could see out and about. So the first component I want to talk to you about is a little bit is the design kind of aspect of the world. So similar to, roadway highway design, we would always start with a survey. We need to know what the existing conditions are. Our survey is a little different than in highway design because, normally track's already out there. So we need to collect things like what are the top of rail points, where are there buildings, where are there other roadways or access points. In the case of that photo, we have a overhead vehicular bridge. We need to know where that bridge is. So we always start off with survey. We like to have survey of all of the points and all of the existing topography around where we're trying to design. A couple other things that we will design are our horizontal and vertical alignments and regressions. So a lot of times if you're taking an existing track and you're able to just move it, we can actually regress it. So instead of having to create a completely new design, we can take what's existing out there using the survey points, and then we can regress it to its new location. Another thing that we will create is, not only where are the tracks going, but we need to look at the profiles. There is very specific criteria for track design of where can the tracks go. Because obviously when you're dealing with highway design, you have a car that's a couple feet long. Well, trains are, hundreds of feet long. So we have to look at profiles, and we need to understand what the site conditions are, because if a train were to ever need to emergency stop, they need to be able to do that. So we prefer to design in tangents. We don't like adding a lot of, having a lot of curves in the profile, because that'll make it harder for the train to stop. So we like having kind of level ground that we're working on. And then the last piece that I've done personally a lot of work in is corridor modeling. So in highway design, that would be your cross sections, but we do a lot of corridor modeling because we need to see how all the tracks are going to react to each other. So in the instance of this photo, this is a yard down in DC. And we need to be able to see, what does track 10 look like next to track 9, next to track 8, next to track 7. So that's when we get into corridor modeling. And we're able to see how these tracks all interact with each other and the surrounding ground, as well as if we have to add things like turnouts or frogs. How do all these pieces work together? So another thing that we do, which I actually designed, these are a quick view of what the couple maintenance facilities we were designing, what they would look like inside. So these are, pretty basic. They were actually being used as in some standard documents to show this would be one way that these facilities would look like, where the track would go and how far they would be from edges of building, and then where we would put fueling areas. So they were very conceptual, very preliminary, but they were interesting to design and kind of lay out what the inside of the building, or if you have tracks on a platform for maintenance underneath, like what would all that look like? So I thought that was a very interesting project I got to work on. So this is just another good example of what a profile would look like, where we're trying to see if there's curves, we're running along a tangent, and then if there is some sort of curve in there, what does that all look like? Are we able to keep that curve in there? Do we need to flatten this out more and do a cut and fill? So this is part of the programming that we'll use within MicroStation to tell us what we need to do. And then with that comes a series of other programs within MicroStation that will tell us things like regression analysis, if we need to put in a new horizontal element, if our horizontal has integrity, if there's any issues with it. So we use a variety of programs within MicroStation to help us design the track work. So next we have construction management. So that would be the oversight of any construction activities that would be along the track. So a good example of that is that top left photo. They're doing some repair work to a railroad bridge. We oversee that repair work, make sure they're not doing anything that could prevent trains from moving or do anything that would put the track out of service. And then we also do construction oversight for when new track is built, such as that top right-hand photo. So, if there's a contractor out there or railroad forces that are building new track, we will provide oversight for that track. As I mentioned earlier, we do perform inspections on existing track. I'm one of my team's inspectors, so we can go out and take a look at the rail and the ties and the ballast, things like that, see if there's any drainage issues and provide recommendations back to the railroad, whether it's a Class 1 railroad or we've done a lot of industry work where we can provide recommendation. And then we can also do oversight on just punch list items or closeout once the construction work is done. So moving on to general engineering consulting. So this is my kind of bread and butter. It's what I've worked on for a couple of years now since leaving design. This was much more kind of in line with what I wanted to do. But this is the connection between the railroad and an outside client. So specifically, we have a GEC with CSX that I work on. And what we do is we provide oversight on behalf of the railroad. So if a client, let's say PennDOT, needs to reconstruct a bridge that crosses CSX, instead of working directly with CSX, they would work through AECOM, and AECOM would provide that oversight on behalf of the railroad. So we help facilitate any projects that might affect railroad right-of-way. So that would be undergrade bridges, overhead bridges, any adjacent projects that might affect railroad operations. And we do that by performing project plan reviews and then preparing force account estimates that delineate any costs for construction oversight or flagging that the railroad may need to provide, and then putting together any sort of agreements. So it's certainly much more consulting focused than design, but I really enjoyed it. I've enjoyed making connections with different railroad employees. So I definitely recommend looking into general engineering consulting if that's something that you'd like to explore more beyond the design world. So this is just a good example of a plan sheet I've reviewed in the past. So instead of producing design, you're reviewing design. So we have railroad specifications and we have ARIMA specifications that tell us what can and cannot be constructed on railroad property. So we design these based off of those specifications. And then we'll coordinate with the railroad if there's anything that they're trying to deviate from standards. Then we can kind of coordinate with the railroad and say, this is what they're providing. This is why they can't construct it to your standards. That's something we need to talk about and we need to work through with them. Another set of work we do is for at-grade crossings. So this is an example of an at-grade crossing with CSX. And this is actually something called an HO1 plan. So what this plan does is it shows you the crossing configuration and then where the signals and signage need to go, as well as showing you where the electrical connections need to be for those signals and other utilities that might be in the area. So grade crossing projects always have their very strict set of criteria because they need to have signals and gates and all the associated electrical work. But they're pretty interesting plans to take a look at and to be able to design. And then, as I mentioned, we do put together agreements and force account estimates for our projects. So I've had an opportunity to do both of these things. So I know a lot about kind of boilerplate agreement language now, as well as knowing a lot about how much projects cost when there is railroad involvement. I've put a lot of these estimates together in my 10 years at AECOM. So it's been interesting to be able to kind of grow that area of expertise as well beyond just like the day-to-day design work. So this is just a good example of what can happen on the railroad if we don't follow specifications, or if we try to do something kind of away from the standards. So railroads tend to have some pretty strict criteria when it comes to things like MSC and T-walls, because of railroad vibrations. So that these photos are a good example of an MSC wall that failed, and the bridge ended up collapsing onto railroad property. So this is one of the reasons why GECs are in place, is we want to be able to review everything and make sure it's up to standard so we can avoid things like this in the future. So just to end real quick, why the railroad? So as I mentioned, the railroad is one of the biggest industries in the US right now. Class 1 railroads have about 96,000 miles of track, but if you add in your short lines and your class 2s and your class 3s and then passenger rail, it's about 140,000 miles of routes. It's nearly an $80 billion industry, and I'm sure it's more now than when I originally got this photo. And it produces hundreds of thousands of jobs every year across the country. So, and that's, whether you're working for the railroad, if you're working for a consultant, if you're working in contracting for the railroad, it's definitely a great industry to be a part of. It's been very fulfilling in my career, and I'm happy to answer any questions you might have about rail engineering or the railroad specifically when I meet you all at the meet and greet at the end of the month. So thank you for joining, and I look forward to seeing